So even though we can't say exactly where electrons are, we can give an estimate of around where they could be on an atom. So let's compare this to if you were giving someone an address. And this person is not from, let's say, the Earth. Maybe they're from Mars. What types of information would you have to give them? Maybe you might start with a planet name. So you would tell this Martian that we are on Earth. Well, once you tell them that, we need to give them more specific information. So where on Earth do you live? And you would probably say North America or the United States, narrowing it in. But they still wouldn't be able to find exactly where you live. So what do you tell them now? Well, you may tell them that you live in Massachusetts, a state. And from that state, you would tell them a city. So we would narrow this down and we would pick out a specific city from this map. So here's a city sign. Still not specific enough. We need to go a little bit further. So you could tell them a street name. And there's one more piece of information that you would give them to tell them exactly where you live, and that would be a house number. So you could direct this person by starting very large on the large scale, narrowing it down, and continuing that process until you get to something very specific. You wouldn't just be able to tell them, I'm house number 31, because they wouldn't know where to look for that house number 31. You have to give them all of this information in order to find where you live. So what does this have to do with electrons? Well, we locate electrons in the atom in a very similar way. So what are the pieces of information we need to locate an electron? Well, the first piece of information is the energy level. And the energy level is very similar to what we showed before with the Bohr model. It's basically how far away from the nucleus is the electron. The farther away the electron is, the more energy it has. And these energy levels are labeled just with the integers. 1, 2, 3, 4, and so on. And the higher the energy level, the farther away the electron is from the nucleus. The second piece of information we need to locate an electron is the sublevel. The sublevel basically just describes the probability density, shape, where the electron is likely to be found. And as mentioned before, these can be the S sublevel, P sublevel, D sublevel, and F sublevels. We also need to know the orbital in which the electron is located. And each sublevel, so the sublevels contain one or more orbitals. So if we have a sublevel that has more than one orbital, we would have to say which orbital that electron is in. Also, every orbital, no matter what type, meaning S, P, D, or F, can hold at most 2 electrons. So it doesn't matter what type of orbital we have, every orbital can only hold up to 2 electrons. The last piece of information we need is the spin. Now, since every orbital can contain 2 electrons, we have to be able to differentiate between those electrons. So, in a given orbital, one electron is spin up, and one electron is spin down. So let's look at some of these concepts in a little more detail. First, if we look at energy levels like we did in the Bohr model, so our nucleus is in the middle, and then around that we have our energy levels, you can see that there's much more room in the energy levels that are farther away from the nucleus than the ones that are close. And we can see this with the number of sublevels that we can have in each orbital. So if we look at this chart, in energy level 1, lowest energy, closest to the nucleus, we can only have the S sublevel. The second energy level has room for more, so we can have an S sublevel and a P sublevel. The third can have an S, P, and D sublevel. And lastly, the fourth energy level can have S, P, D, or F. Everything higher than 3, so 4 and up, can have S, P, D, or F. And just as a reminder, let's look at what these sublevels look like. So our S sublevel looks like a sphere. Our P sublevels look like these figure 8 shapes, and there are 3. So when I say that energy level 2 has an S sublevel, that means it has one S orbital, and it has a P sublevel, meaning it has 3 P orbitals. So for a total of 4 orbitals. If we look at the third energy level, where we have S, P, and D, we have an S orbital, we have 3 P orbitals, and we have 5 D orbitals that are present. Now, if an element has electrons at the third energy level, it doesn't mean that each one of these sublevels is filled or that each one of these orbitals is completely filled. Remember, each orbital can have up to 2 electrons, but it means that these orbitals exist. So if we did add extra electrons, there would be a place to put them. If we now look at our sublevels in a little more detail, we can see that our S sublevel, as shown in the picture, only has 1 orbital. The number of electrons that can fit in that orbital is 2, so the total number of electrons in that sublevel is 2. In the P sublevel, we have 3 orbitals. If each orbital can hold 2 electrons, remember it doesn't matter what type of orbital we have, it can only hold 2 electrons at most, we can have a total of 6 electrons. The D sublevel has 5 orbitals. If each orbital holds 2 electrons, that means it can hold up to 10 electrons. And the F sublevel has 7 orbitals here. And if each holds up to 2 electrons, we can hold up to 14 electrons in an F sublevel.